Hi, everybody. So this is going to be some notes for section 2.05, and which I think you guys are going to like because we are still using the GPE and KE formulas and total mechanical energy or just total energy formulas, but we are adding numbers. So this first one is how to calculate. It's just an example of calculating GPE, KE, and total mechanical energy. And the two rules: convert to your correct SI units first and solve using guide. So the first thing we're going to do is we're going to read the problem. Rose and Sean are moving on different floors in a two-story building as shown in the drawing to the right. Determine the following. So we're going to take a look at that. I'm going to, first of all, we're going to look at the units. So we've got mass of 50 kilograms. Great. Mass should be in kilograms. We've got a speed in meters per second. Great. That's what the SI unit is for speed. We've got some heights listed here that we'll talk about in a second in meters, which is great because that's the SI unit. Same down here, kilograms for mass, meters per second for speed. So the first thing I'm going to do that we should have talked about in class earlier today or some other day is set a reference height. And this is my reference height of h equals 0. Sorry, it takes me a long time to write with this pen. It's a little messy. It looks like a pear, I think. Whatever. Which means that Sean only has KE. He doesn't have a GPE. He has KE because of his 10 meters per second. So we'll put that there for him. I should have done this on my iPad because I can write faster with my finger on my iPad, but when I type later, it's easier to do on my computer. Anyway, and then it means that Rose is not on the ground, so she has GPE, and she's moving, so she has KE. So I'm going to write that on there because I said probably last week that part of your givens and guide can be just written on your diagram. Whoa. And we always, 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 always label the types of energy. So for right now, it's just going to be GPE and KE. And then starting soon, we're going to also add in EPE, but don't worry about that. Okay. So now we're going to type in some givens that we have from our diagram. We're going to write down that the mass of Rose, is equal to, oh wow, 50.0 kg. Oops. I'm going to move over a little bit, and then I'm going to talk about her height. So height of Rose. And last week, whoa, sorry about that. Last week we talked about the height of a person is how far their feet are off the ground, and we're hopefully talked in class about the ground being h is equal to 0. So how far a person's feet are from h equals 0. So she is on this line right here. That's where her feet are. And this line is 4 meters from the ground. So remember, this 4 meters means it spans from here to this line. If Rose was on the roof of the building up here, she'd be another 4 meters up, and she'd be on top of the building. She'd be 8 meters above this line, but she's only 4. So we're going to include that 4.0 meters. That's her height. Okay. And then G is, we're just always going to use 10. So I'll just write G equals 10. I don't need you to put a unit. And if we want to, we can put Sean's stuff in there right now. I could basically just do these together, but maybe I'll come back to his. Okay, so we're just doing Rose. She has GPE, she has KE. Great. Our unknowns are E Rose and also E Sean. Oops. And then the unit that what we're going to use is E total. So there's three things we need to use. E total equals GPE plus KE. We need to use GPE equals MGH. We need to use KE equals, I'm just going to write 0.5 instead of 1/2. It's quicker. And then V squared. So I'm going to write this little caret to mean square. Okay. Those are the three pretty much that you're always just going to write down. Okay. So we're going to do three things. We're going to find out what's the GPE of Rose. So that's going to equal her mass of 50.0 times G, which is 10, times the height of 4.0. So basically, I just plugged into the formula where it says MGH. I plugged in the mass, M, G, 10, and the height, H. What we're going to do is we are not going to use the sig figs on G. We're only going to use the sig figs from the mass and from H. So don't worry about the sig figs on G. Otherwise, all your sig figs would just be 10. So all we have to do is multiply 50 times 10 times 4. And if we do that, we'll get 2,000. So it should be 2,000 joules. We're going to leave it. I'm going to put in parentheses here 2 sig figs, and I'll just explain that in a little bit. It should be 2 and 2 sig figs because 4.0 is in 2 sig figs. We're going to end up adding this later to her KE, which we're going to calculate right now. So it's possible that when we add them, they'll already have 2 sig figs. If not, we'll use scientific notation, and that's fine. All right. So for her KE, we're going to put 0.5 times her mass, which is 50.0, times her speed, which is 4.0, squared. All right. Again, we're not going to use sig figs on a half. We're just going to use the 50 and the 4. So sig figs on those. Whoa. So what we should get is we get 400. Okay. And again, 400 joules. So joules are the SI unit for energy. So again, that should be in 2 sig figs. All right. And again, we're just going to add them together and see what happens. So our E total, or our mechanical energy, which is E total. I don't know if you guys heard that. That was just the dog getting off the bed. Is going to be equal to 2,000 plus 400. And when we add those together, when you add with sig figs, you're supposed to keep the same, you're supposed to look at decimal places. So 2,000 doesn't have any decimal places, and neither does 400. So when you get your answer, you're supposed to round to the nearest whole number then. And we will get 2,400 joules. That has 2 sig figs already in it. I'm not going to worry about writing these. It really, like I said, it really doesn't even matter. If I wrote them, I would add 2.0 times 10 to the third plus 4.0 times 10 to squared. And I would end up with a number that has 2 sig figs in it anyway. Okay, so we're going to skip the E for that for right now. All right, we're going back to this. I'm going to get cut off in a second. So I'm going to try and be quicker with this one. So the mass of Sean we have from the diagram is 70 kilograms. His height is 0, and we're going to write down that G equals 10. So for him, his total mechanical energy is going to be just his kinetic energy, because we know his GPE is 0, no height, because he's at a height of 0. Okay, so now we do KE of Sean, and that's going to be, we're just going to plug in 0.5. We're just plugging into this formula, my friend. 1/2 mv squared. His mass is 70.0, and his speed is 10.0. So he's going to have a ton of kinetic energy. We're squaring that 10, which gives us 100. We're multiplying by 70, which gives us 700. And we're cutting it in half, which gives us 350 joules. Well, maybe he doesn't have a ton of kinetic energy then. Well, that's not right. I screwed something up. Let's go over this. All right. That's what it is. 10 squared is 100. 100 times 70 is actually 7,000 cut in half. So 3,500 joules. Yay, it's in 2 sig figs, which makes me happy because 70, actually, it should be in 3 sig figs. So screw that. I'm not happy anymore, but that's okay. So let's write 3 sig figs. Actually, I'm going to have to write this in scientific notation then. So it's supposed to be in 3 sig figs. We'll write it down here. So our E total, got it. Oh, we got to stop in 28 seconds, is equal to GPE, which is 0, plus the 3,500. Oh boy. Which equals 3.50 times 10 to the third joules, and that's in 3 sig figs. All right, I'm running out of time, so don't worry about E for right now.